All right, this video is for Carson and Reese and for Daniel and whoever else wants to watch it. This is 6-9. A lot of this stuff we've done already before, but we're going to talk strategies and we're going to talk some tricks that they might throw at you, okay? So 6-9 is only front-sided, but I do have some things on the back that I want us to write as soon as we're done with these examples. So don't put your stuff away. We've got some things to do. So example 1, this guy is log with a base of 36, and normally we don't see bases that are that big, but it's fine. It's the same as what we've done before. We're trying to solve for x, okay? This is a log function. And to solve for x, like we try to do different things, whatever, what do you want to do? Make it an exponential function. That sounds like a really good starting place to me. So exponential function, this is 36 to the 3/2 power equals x, okay? You can type in 36 to the 3/2 power for those of you who care to know. The 3/2 power means the square root of 36 and then to the third power. The 2 on the bottom makes it a square root. So the square root of 36 is 6, and 6 to the third power is 216. That's what that becomes, okay? You can just type in 36 to the 3/2 power and get 216. But that's what that means, okay? We've already done this stuff before, right? B, if we make that guy an exponential function, what does he look like? 16 to the 5/2 equals x, okay? If you care to know, 16 to the 5/2 is the square root of 16 and then to the 5th power. The square root of 16 is 4, so this is 4 to the 5th power, which is like 1024, is that right? Yeah? 1024 equals x. That's what he becomes. We've solved this way before, right? We've done these, making him to an exponential function. 1024. I can?
So
What?
we change it to an exponential.
Yeah.
36 over 3/2. So that would
Okay.
be 6 to the 3rd power.
What? 6 to the 3rd power. Yeah, exactly. Okay? All right. Example 2 is kind of nice, and then we get to a point where it's kind of ugly at the same time. So here's my equal sign, and we've done a strategy like this before that says if there's a log on each side, we can cancel them out. Now this one, I'm going to kind of try to ask you an interesting question. Do we have to put like these two together, because doesn't minus mean divide? Like normal, it's already put together, right? X squared minus 4, that is under the same log. So they are technically already put together. So don't think that when there's a minus sign, you have to put them together, because they're already under the same parentheses. They're already put together, okay? So I wanted to kind of bring that to your attention, so if you see that later on, you don't automatically think I have to put them together, because they already are. In this case, we have 2 logs, we can cross them out. What? Because they're under the same parentheses. They're already one unit together inside of a log, right? Okay? If they weren't together, then they would have like 2 separate logs and 2 separate parentheses, okay? So here we can just cancel the logs, and this one, x squared minus 4 equals 3x. We cancel all the stuff out, and what'd you say? This is a trinomial. We have an x squared, an x, and a number. So when we have a simple trinomial, we want to get everything onto the same side. Let's put the 3x over. I like that idea. Minus 3x, and let's put everything in order. So we have equals 0. How does that stuff go? X squared? Minus 3x minus 4. No, not negative for both. We want to break them down. Multiply to get negative 4, but when I add them, give me negative 3. X minus 4 and x plus 1. Okay, good. Now, I set each one of them equal to 0. So if x minus 4 equals 0, x is actually equal to positive 4, and x is actually equal to negative 1. Yeah? Beautiful. Okay, x equals 4, x equals negative 1, except there's a little note right here that says, note, taking log of 0 or a negative number yields no solution. So the only answer that I have is x equals 4. That's the only problem that I have, or the only solution that I have. X equals 4. We're gonna talk about exceptions to that rule here in a little bit. Okay. All right, so x equals 4 for now. Let's go down to example 3. Just because we have an inequality doesn't really change a whole lot. We've got that greater than symbol, but we have log base 3 of x is greater than 4. What do you want to do here?
So it would be
Base of 3 to the
fourth power
is greater than x. Yeah, right? We make him an exponential function. That's the strategy, exponential. Okay? 3 to the 4th power is 81 is greater than x, or x is less than 81, and there we have it. Right? Not too bad. Okay, part B, same kind of type of thing. Here's my equal sign, or my greater than symbol. And this one's a log. We want to make him into an exponential function. So, 4 to the 3rd power, what? X is less than 81. Yep. Okay. 4 to the 3rd power is greater than or equal to x. It is 64. 64 is greater than or equal to x, or x is greater or less than or equal to 64. That's how that works.
Did you say x is less than 81 or
81 is greater than x, or x is less than 81. Thank you. I don't know. What? Okay. Just like that. Okay. Good? Are we good, Josie? Yeah? Okay, let's go down to this one now. Example 4. This one's probably maybe the easiest one of the whole sheet. There's my equal sign. Can you cross out the logs, or do we have to combine anything?
Yep, you can cross
Because these are already combined. Josie, do you see that? These are already combined. This is all under one log, so we can just cross. Nope. Cross. Okay? X plus 3 will be greater than 2x plus 1. Now let's combine some stuff or move. Minus the x, okay? 3 is greater than, what's 2x minus x? 1x, or just x, plus 1, okay? Let's minus the 1, so 2 is greater than x, or you can say x is less than 2, okay? Don't put your stuff away, because I've got some strategies on the back side I want to show you. Here's some things that may happen to you, because they try to be really mean. Okay? Good? Yeah? All right, let's go to the back. Strategies. First of all, one strategy, like you have something like this over here. And this is the strategy that you're going to use when you have a log equal to a number or equal to something. I know we've written this down on a paper before. I know we have. When you have a log equal to a number, like this one here, what is the strategy that you do? Make into an exponential function and then solve. Okay, so this guy right here, log base 4 of x equals 2. If I make that into an exponential function, he is 4 to the 2nd power equals x, and then x equals 16, because 4 squared is 16. That's how you would solve that, right? That's your strategy. Yes, ma'am.
hold on, I'm ready to know.
Okay.
Um,
Wait. Yes.
So if it's just log to no power, is it just 10 then? Or like
Yes.
subscript?
Yes. If it doesn't have a subscript, it is 10.
make
Yep. Good. Okay. The second strategy is if you have a log equal to a log.
How many strategies are we doing?
Just 2. But then I have 2 more examples down below. So just wait. A log equal to a log. Shoom. You cancel both. But only one each side. Which means, I'm going to put in parentheses, you may need to combine. What do I mean by combine? Add logs or combine logs, like this example over here. I gave an example. This is a 5x, by the way. Let me rewrite him. Equals log of 5x. So this is an example like what you were talking about. We have no base. His base is 10, right? Okay. So if we're combining stuff, here's my equal sign. I can't just shoom, because there's 3 of them. I have to have only 1 on each side, which means these 2 need to be combined. And what's between them? Plus, which means multiply. So I'm going to multiply those 2 together. So this becomes log of 2x plus 2 equals log of 5x. Okay, now you can shoom. 2x plus 2 equals, this doesn't come out nicely, but we're just going to leave it as a fraction. It's okay. subtract, right? Subtract the 2x, subtract the 2x. 2 equals 3x, and then divide by 3. Don't put this paper away because I got 2 more things I want to add.
2/3. I'm not done writing.
2/3, okay.
Hold on.
I will wait. Because it's going to take me a second to come up with these examples. So give me just a minute.
Okay.
Okay, I'm going to do 2 more examples to you. I'm going to put one here, and I'm going to put one here. And don't write this down yet because I don't know which one's going to work. So I got to do it in my head, and I'm going to see if this works, but don't write it down yet because I'm going to change it probably. So let's say I got to look at an example. Yeah, let's do that. That's the one that I want. Okay, so write that one down, and then I'm going to write down another one. I'm going to write down... I'm going to write this one down.
Should we subtract the 2 and go to 64?
What?
We take the 2
No,
and 64?
no. Okay, we ready? Have you guys figured out the left one yet? You did? Maybe? Did you plug and play?
Is that
No.
where it's well, you can basically do it from
Kinda, maybe. Kinda, maybe.
Wait, I
Okay,
can't even
so
see what the other one says.
just wait. I'll pan over to it here in a minute. Okay, so this guy. What the heck are we gonna do there? Like, what's the strategy? What strategy do we use? Let's make it into an exponential function. Okay, what's the base gonna be? 4, right? Is the base of the log, right? Even though the log's on the right side, 4 to the x plus 2 power equals. Now, how the heck do I solve this thing? Yeah, this was like what we did at the very beginning of the chapter. 64 is the same thing as 4 to the 3rd power, right? You remember a long time ago where we did this? So x, the left side stays the same, but 4 to the 3rd power is that guy, right? 4 to the 3rd power. Now what? Now I cross out the 4. So this is still a thing. You could still have a problem like this. We minus the 2, so x is 1. So I'm just showing you that when you switch it around, you still might have to do the like whoop-de-doo thing. Because 64 is 4 to the 3rd power. So we're just rewriting him like that with the same base, right? That could be a thing that you still have to do. Okay? Okay, that's log base 9. So this example is a homework problem. I am literally doing a homework problem for you, and I will tell you it is number
Can you zoom in on it?
6. What? This one?
Yeah.
Okay, hold on. Josie, are you down with the other one? No?
But I can figure it out.
Okay, so here we go. This guy. This is homework problem number 6. So when I give you your homework sheet, you can just write the answer down because we did it together. I won't make you copy the work down again. But write this on this note sheet because I want to bring this to your attention also. This is a really hard one. Okay? All right. What do you got? What'd you do?
Cross out the log.
Cross out the logs. Okay. I agreed. 3x squared equals 2x plus 1. Now what?
minus 3x squared.
Make it into a simple trinomial.
No.
Minus 3x
It's a complex trinomial. I always want my x squared to stay positive.
So minus 3x.
I'm going to minus these guys over here, right? Okay? And you can make your x squared negative. It's not going to be that big of a deal. But I just always like to make him positive. So I'm going to subtract the 2x here, subtract 2x here, subtract the 1, subtract the 1. So equals, on the right side, I will have 0 now because he's gone. And so you get 3x squared minus 2x minus 1. Nope.
Can't see it.
Okay, so we've got that. Okay? But the problem here is that this is not a simple trinomial. It is
You have to
a complex one, right? Okay, and some of you guys already know what the strategy is. 3 times negative 1. is negative 3. Okay, I want to multiply to get negative 3, but when I add them, give me negative 2. Okay?
There's 1.
Negative 3 and positive 1.
Negative 3 and positive 1, right? Because I want it to be negative 2 when I add, all right? So, now what do we do with that?
3x squared minus 3x
Plus 1x minus 2. It's like this guy splits into these two pieces, right? Okay? And now,
Wouldn't it be,
okay?
what?
And now I
Wouldn't it be
group,
minus
and I
2?
group. Oh, well, not minus 2. Thank you. I don't know what I'm writing. I have no idea. Minus 1, that's a 1 right there. Okay?
And 3x squared.
Yeah, that's 3x squared.
Divided by 3.
Okay? So, what are you going to take out of the first bubble?
3x.
3x, okay? And left over is x minus 1. You still have to have the 1 there. Okay, what are you going to take out of the second group?
1.
Yeah, nothing. You can't take anything out, really. But you're going to take out a 1. So, x minus 1 is the thing, right? Okay? So, I'm going to, my two bubbles finally are
3x plus 1.
3x plus 1 and
X minus 1.
x minus 1. Okay, so then I set them equal to 0, and I know this one's going to be x equals positive 1, right? Okay? Now, hold on. Just wait a second, Reese. Wait a second, Reese. This is the trick. You set this guy equal to 0. Minus 1, minus 1. This is the exception to the rule. Hold on. I'll show you. 3x equals negative 1. And then divide by 3 and divide by 3. So x equals negative 1/3. Do we see how we got that? Set them equal to 0. X equals negative 1/3. I have two answers. And most of the time, when we plug in, like we can't take log of a negative number, ever. We can't take log of a negative number. But here's the deal. This is the exception to the rule. If I plug negative 1/3 into the original function, which is here, let me erase this stuff right here. If I plug negative 1/3 in right here, negative 1/3, and I square it, it's going to be a positive number. So you will end up taking log of a positive number here, right? Because you squared it. Okay, let's look over here. 2 times negative 1/3 is negative 2/3. But then if I add 1 to that, what's negative 2/3 plus 1? 1/3. A positive 1/3, right? That's log of a positive number. So even though the answer was negative, when I look to plug it back in, am I going to end up taking log of a negative number? No, that's the only exception to the rule. So you have to kind of look at that just a little bit to see, will it end up being a negative number when I plug it in, right? Okay? Same thing with 0. If you get 0 as an answer, that doesn't necessarily mean it's not an answer. If you plug it back in, are you taking log of 0, or does it end up being a positive number,
So if it was
right?
like log of 9, for example, and it was 3 or 0 plus 3.
Log base 9 of x plus 3, let's say. And you got x equals 0.
Yeah.
Is 0 going to be an answer, or is 0 not going to be an
That's
answer?
going to be an answer because
Because if I
three.
plug 0 in here, I'm taking log of 3.
Okay,
So that still works. That's not a non-solution, right? Okay, so that's the exception to the rule. So you have to kind of be, it's kind of tricky, okay? Do you guys have homework assignment yet? No, you don't. For the people in the video, we're going to do, what did I say? Evens on both sides. Yeah, get you out of a story problem. Evens on both sides for 6-9. There you go. All right, goodbye people in the video.